Okay. Right, okay. The next talk. This is one of the things I've been wanting to work on for quite a long time, which is cleaning up the SCSI logging. And I've been working on this one on and off for, well, several years now, always trying to figure out, all right, what could we do, and it doesn't look good, and then discarding this attempt. And this is finally the last, or the most recent one, which actually looks quite promising. So, the problem here. Printk, everyone knows Printk. Yeah, sure. I mean, Printk is simple. You just do Printk and then it prints. So, it's actually a dead simple interface. You just have the logging level, which actually is just a string, which then will be just concatenated with the information next to it and printed out. So the logging level itself is a string in the message and will be interpreted by the syslog daemon in user land. That's the default level, okay. The important thing is that messages are normally flushed out after, if you insert a new line, which can be used for a concatenation. So if you don't insert a new line, the message won't be flushed, so you can actually concatenate things. Then, as most of you know, there's a def Printk, which is just a convenience function, which allows you to pass in the logging level as a separate argument, and you can also pass in the device, which is a struct device in this case, which then will be nicely formatted, and you have it automatically in your syslog message, and you don't have to worry about, oh, where again do I get the name of this device. As you can see, I mean, this is a bit awkward to print. And of course, you got tons and tons of derivative of this one, like sdef Printk, USB, whatnot. Every substance basically has its own derivative for that one. Okay. But with def Printk, we cannot really do a concatenation. And syslog, so both do the same message, so why bother? Well, there's one important thing. With 3.7, Kai Sievers managed to update the Printk subsystem. Previously, it was just a ring buffer containing string messages. And he replaced the ring buffer with a ring buffer of structured messages. So it's not a plain string buffer anymore, but rather it actually has a fixed format with a binary header on top telling you what the message was, what it belongs to, what not. So the main trick here was that he removed the old timestamp, which was a string inserted in front of the message, and replaced it with his binary header, reformatting and just inserting the timestamp as a binary value. So all the space he saved by just using this binary value, he could reuse for something else. And in addition, as you now have a binary header, which can contain some structured things, you can actually insert a dictionary here. So you can insert a structured message in there, which allows you to parse additional information. So you're not only having the string, but also some additional information to that message. The dictionary is similarly organized like the U-event structure, so you have a length of which, and then, so you have the length of a dictionary, and then individual entries, each separated by ASCII 0. And obviously, if you want to transfer binary data with that, you do need to escape it or transpose it altogether. So that's what it looks like now. So first is the time in nanoseconds. Then it's the length of the record, the length of the text, and the length of the dictionary. This is the logging level, the facility and the level. And this is the actual string. And here, this one is the dictionary. This is, here you see that's the 0, so that's device B2, B for block. So it's SCSI SDA2 in this case, and driver, whatever bug it says. Anyway, so that's what it looks like. And you can actually see this one via the new device node def kmesc, which gives you an ASCII output of the Printk buffer, including the dictionary. So you can actually see what the message was and what the dictionary is which goes with that message. Which is quite handy, because you can then have a user space logging daemon, which not only allows you to log it, but also allows you to zoom into the two messages for individual devices, because you know now exactly which devices this message belongs to. So you can tag the message with the device and just filter out those messages for these devices, which is quite neat. So I thought, hey, that's a cool concept. Really? Bomber. Right. I said, hey, that's a cool concept. Let's see what SCSI does. Yes. So SCSI has its own logging system via proxys dev SCSI logging level. As you can see, that's a rather old interface, because that's this is the only entry into sys. SCSI is the only entry into dev, and logging level is the only entry into SCSI. So it's not once obsolete, but 3 times obsolete in this case. Anyway. Yeah, because that's neat indeed, yeah. But so you still have to remember the magic entry point. Oh, which was sys? Yes, indeed. So, right. So then if you enable this, it prints out additional message to what you did, what the command was, what the command book was, what the result is, blah, 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 yada, yada. Okay, that looks nice. However, if you have several devices and more of them faster, it looks like this. So you have the same information, but here should have been a concatenation, but then an interrupt came in and interrupted this, printed out that one. So this one actually belongs on that line, obviously. Same goes here. So here the interrupt came in, but then he sent it another one. So this here actually belongs to here. And each of these bytes are obviously individual print case. So under really high load, even that one is split up, and you got random numbers splattered across the entire syslog string. Makes wonders for debugging. And this was the nice output, because on 3.7, the rules for concatenation got somewhat tightened, so now it looks like this every time. So you have a send, and then there's the pointer. CDB followed by the string, and so on and so forth. If you have under high load, this is impossible to debug. You have no idea what's going on. And then obviously, there are some drivers which do not attach any information at all. Just print, all right, I did this, I did that, I did that. All right, nice, but which device again? So I said, all right, this cannot be like this, because at the end of the day, if that ever becomes our standard kernel, I have to debug it. No. So we could use dev Printk here. So just use dev Printk and actually prefix it with the device. And suddenly you see, it's that. Yeah, you should have told me so. And the other thing, really painful thing, you have to get rid of all the implicit concatenation. So you basically have to allocate a separate buffer, write the entire message in there, and write it out in one go with one Printk. Because then that's the only way how you could avoid any any message interruption under high load. So you have to print out in one go. And there's even some nice Printk formats like %6ph. Does anyone know what that means? Anyone ever seen this? Anyone ever used it? Good. Right. Now, Printk actually has some advanced formats. So you can print all nifty things like kernel pointers, the functions the kernel pointers references to, the resources being printed as resources, and so on and so forth. So if anyone ever does some Printk things, look in libscn_printf. There's all the formats listed what you can do with. Really helpful. So use a Printk message here, and then it suddenly becomes nice and readable. And the other thing is, you could actually, there's a missing example, okay. Right, so you could actually do a format the sense code. Each SCSI command has an additional information if the command went wrong, which is called a sense code. And this you can just add as a dictionary to provide structured access to this, which has to, so once it's nicely formatted, and on the other time, it can also be evaluated from user space. So with that, hey, we're there. I've posted this patch set 2 weeks ago, and so far responses have been nice. Well, the one response I got were okay, and the other, and I'm waiting what happens next. Probably nothing. So, next things, what could we do with this? The one thing is, we could actually have a daemon now, because we could have a daemon listening on the KMS thing and grabs out all the sense messages and does trigger some action of that. And we could have a look at the SCSI logging system, because currently the SCSI logging is global. So you either enable it or you don't. And if you enable it for all devices. So, which is really, really annoying if you have a SCSI only machine, because if you enable it, you will log the logging, because then it'll log all commands it needs to print out the log which you just told him to print. So it's really, really getting really, really long fast, just so because it logs the logging. So normally what I end up doing is just switch off syslog and then do the measurement, which means that I don't really have a syslog, so I can't really store what's going on, which is a bit annoying. So what I want to do here is to move that into the device so that it becomes a property of the device, so that you can enable logging per device and not just globally. So with that, I'm done and open to questions. Yes?
So now that trace events are essentially free, why couldn't you use those instead? And then you'd get rid of the performance impact that you'd have when you're running it, especially when you have a console that's going to be dumping everything.
Yeah, well, this is just because that's the existing infrastructure. Because, this is what we tell the customer to enable if we want to trace, if we want to debug something. And as you've seen with 3.7, it's completely unreadable.
Yeah.
So it needs to be converted anyway.
Yeah, I'm just thinking about it from the perspective of you want to have a complete, you want to be able to dump all this information from a SCSI command, and if you do it with trace events, then it's all just saving off field values at the point where you're dumping the event, and then when you're actually reading it, then it's going to do all the printing. So you can sort of do that out of band, and then you end up not putting quite such a load on the system.
Probably, but again, I mean, the infrastructure is there, and if we will go ahead and convert this, we have to be really careful to discuss each step with the community, because there are some who have a really strong idea of how it should look like. So yes, trace events would be a good idea, but try to convince James Bottomley from that. I'm not sure we get very far with it. So,
I believe that.
Another question? Yep.
I thought it's possible for the K-message buffer to wrap around. Is it still the case?
Yeah.
So if your user space is too slow, would it be a good idea? Like that sense daemon you were speaking, we were talking about, it would be possible for it to lose events in terms of...
Well...
I think that's mostly the similar question, like the person
No,
for me.
the problem is slightly different here. So you will have to have an efficient mechanism for logging, obviously. So you simply cannot allocate memory if you do logging. Because if you do that, you might not be able to have memory to allocate it from. So you might not be able to log. So you need to pre-allocate logging memory anyway, regardless what you're doing. So you inevitably have a fixed space. Again, independent of which mechanism at all you're thinking of, you have to allocate a fixed space, which will always wrap around, giving enough messages. So the only thing which you can do is reduce the amount of messages you have, or pick them up fast enough, or live with it that some message will be lost. Yes, that is true. But currently, yeah, but still.
So eventually you can wrap, but if you configure the size of the buffer large enough, if you're expecting something like that to happen, then the wrapping won't really.
Yeah, exactly. You can. I mean, that's what you would normally do.
Yeah.
You would just measure. All right, how many messages do I get worst case, and make the buffer large enough. Yeah, sure. Obviously, that's what you do. But still, it is not 100% guarantee that that the buffer won't be wrapped around. So you always have to live with the fact, yeah, I might be losing some messages, but yeah, hell, that's life. I'm not doing anything with messages currently, so can I get better, can I? So, but yes, you're right. Yes, we will be losing messages, and we can only hope these weren't any important messages. Or I don't, yes, maybe there might be better ideas, but currently I don't have it. Any more?
You could attempt to log to a separate device or network serial console, because then you have a separate machine that can always consume the messages.
Yes, you can attempt to. But then, if you log via network, you need memory. If you log via serial console, you need interrupts. So the only real choice you have is to, I mean, the most secure method you have is dump to VGA. Because with that, you always have VGA memory, you don't need interrupts. Some machines don't have VGA, which is a bit bad, yeah, right, but still. I mean, that's literally the only reliable choice you have if you want to do, if you care about this. Otherwise, you always end up with some difficulties, like networking. For network, you do need memory to log things, because you do need memory to send out packages. And in most cases, and for serial, you do need interrupts. We can talk afterwards with many interesting things, calls we had with this serial console locking up under high load. So yeah, no, it's tricky.
It'll also massively queue up and make your system grindable while you have a whole lot of logging in serial console.
So, any more questions? And thank you very much, and enjoy your talks.